Hi, thanks for tuning in. Today we'll be discussing the sourcing model we created for our campus's dining facility, which is called the DUCling. First, we'll give a brief overview of what the model does and the data that we collected and used in our model. Then, we will go into detail about the model's intended use and briefly discuss the algorithm. On the first page, as you can see, we've input form controls that list 6 different ingredients, and they link to sheets in which the specific sourcing optimization models are stored. The data that we use to create the optimization model for each ingredient is broken down by the dining hall's demand for lunch and dinner on the weekdays and brunch and dinner for the weekends for both the fall and the spring to control seasonality. So just getting a closer look, here's some of the model or the data that we collected from our dining facilities. As you can see, it's broken down by lunch, dinner for weekdays. We computed averages for weekday lunch, weekday dinner, weekend brunch, and weekend dinner for data in the spring and data in the fall to kind of give us a holistic look. And after taking averages of this data, we simulated demand, which we'll go into a little bit more in the future in our optimization model. So let's look at how this data is used.
We will start by looking at the model for tomatoes. On this ActiveX control, the user can select which semester they are in and the mealtime they would like to look at. For example, let us look at the spring semester, and the mealtime can be weekend dinner. We will go ahead and optimize the sourcing and take a look at the ins and outs of the model. After clicking the Optimize Sourcing button, the model outputs the quantity that should be ordered from each supplier and the corresponding total cost. If we look at this particular example, we can see that the optimal cost can be yielded when we order 3.8 pounds from Flavor First, 11.41 pounds from Riverview Farms, 19.01 pounds from Turnip Truck, and lastly, 3.8 pounds from Local Lions. The corresponding total cost of tomatoes would be $441.45. We gathered data about ingredient costs by farm, and which are listed in this row. We then looked at the distance of the farms to Emory and used distance as a proxy for transportation costs. The decision variables in our model are the order amounts by farm, measured in pounds, respectively, and the goal is to minimize the total cost while meeting demand. We have 3 constraints in this model. The first constraint is that demand must be greater than or equal to total student demand times a dampening parameter, which will be discussed further in a minute. Below the constraints are the parameters that we used in this model. The first parameter is the percent of student consumption of that specific ingredient, which in this case are tomatoes. And the second is the average serving size per student. These were multiplied by the simulated demand, which we discussed earlier. The final parameter is a dollar per mile parameter that corresponds to the travel costs. These parameters can be adjusted as necessary. After running the model, the optimal order amounts by supplier will show up in these yellow cells. We did this by the use of VBA programming.
When the Optimize Sourcing button is clicked, the model pulls a simulated demand based on the semester and the mealtime. Solver is used to optimize the sourcing quantities for each location, given the constraints within the code. Then these values will populate in the text boxes. We've also included charts and analysis that graphically display the results of the model. The pie chart breaks down the order volume by supplier, and it repopulates based on the user's inputs. We also did a cost parameter analysis that looks at how changes in price of the cheapest supplier will affect volumes ordered from other suppliers and total costs, which is graphically displayed here. After determining the optimal sourcing of tomatoes, you can click the Return to Homepage button and analyze optimal sourcing for other ingredients.